फाइल, हाँ एक बार दिखा दीजिए। इसी में से याद ज़्यादा यूज़ करना है, इसे खोल के रखिए। आता है आप लोगों को इंटीग्रेशन? फॉर्मूले याद है? ठीक है, फिर हेल्प करना मेरी। डेली याद रखा करो, इन्हें चार्ट बनाए हो आगे, उठते ही उसके दर्शन करो। ग्रेट, पढ़ाई चलती रहती है इस प्रोफेशन में। दैट्स गुड। आई डिड ग्रेजुएशन फर्स्ट, 2000 से स्टार्ट हुई थी ग्रेजुएशन, फिर 2 साल की मास्टर्स, फिर एमफिल, दैट टुक 3 इयर्स। नहीं, दैट्स नॉट नेसेसरी, वो मैंने ऑन इन जॉब ही की है। देन आई डिड एमएससी अगेन फ्रॉम यूके इन अदर सब्जेक्ट, फाइनेंशियल मैथ्स, एंड पीएचडी अभी करना है। मार्कर फॉन्ट थोड़ा बड़ा होगा। आई डोंट नो, जो वीडियो में नजर आए। मे बी मुझे बड़ा यूज करना चाहिए फॉन्ट। रीड नहीं, कैमरे से विल दे बी एबल टू रीड इट? क्योंकि मैं पिछला देख रही थी तो हम्म। हेलो 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 हेलो। ऑन करना है। हेलो हेलो हेलो, सेल वर्किंग है? हेलो, हेलो, आज आधा घंटा लेट कर। हाय हाय, आ रही है? माइक टेस्टिंग। वर्किंग ना? Hello students. Hello students. So far you have discussed the techniques to differentiate a function, right? We are now going to reverse this process. That is, we will try to find a function whose derivative is known to me. Okay? And this process is known as integration. So if a function f has derivative g, okay, then we say that integral of gx is the function f. Okay, this is the mathematical notation. Here gx is known as integrand. Okay, x is the variable with respect to which we are integrating. Okay, integration is here with respect to variable x. All right, this is the sign for integration, as you know. Okay, so this thing is integration of gx is dx, right? Now you know, if derivative of fx is g, then for any constant c, the derivative of this function fx plus constant is f dash x. What is derivative of constant? It's 0, so which is gx. So if derivative of f is g, then derivative of fx plus c is also g for any constant value c. So by definition, what we have, the integral of gx is in fact a class of function or family of functions fx plus c. Okay, for different values of c, you are going to have different functions. Okay, that's why the term indefinite integration. Okay, we have the notion of definite integration as well, which we will discuss in later sessions. Okay, so this is the notation. Integration of gx is not just fx, but fx plus c. Now, can you change it? Not every function is integrable. Just like not every function is differentiable, every function need not be integrable as well. Fine. But we have certain classes of functions which are necessarily integrable. One such class is continuous functions. Okay. Every continuous function is integrable. Fine. In fact, a function, yes, a function with finitely many discontinuities is also integrable. Okay. So you have so many integrable functions now. Every continuous function, every polynomial function, every trigonometric function, rational function, all are integrable. Fine. In fact, if you have countably many discontinuities, then also the function is integrable. Okay. And another class is class of monotonic functions. Every monotonic function is also integrable. Fine. But it may happen, and we call this, when I write this integral gx dx is fx, f is also known as integral or antiderivative of g or primitive of g. Okay. So it may happen that the antiderivative exists, but it is not possible to express it in known functions, like in terms of polynomial functions or trigonometric function or any known function. Then we say this integral cannot be found. Okay, integral gx cannot be found, but don't worry, we will be discussing only those functions which are integrable, though there are certain non-integrable functions or where derivative cannot be expressed. For example, this function, the function sin x by x dx, these are some examples where antiderivative cannot be found. Okay, and there are many more. Okay. So we have to learn how to find this integration. And there is not a unique way to find integral of a function. Okay, you will learn it only by practice, but we will try to cover as many forms which we can, okay, which will be helpful in integrating a function. We will know that in certain this form you need to proceed in this manner. Okay, so from the definition only we have certain set of formulas. For example, this formula 1, this is integral xn dx is equal to xn plus 1 by n plus 1. Obviously this expression makes sense for n different from minus 1. Okay, for n different from minus 1 we have this. This directly follows from the definition, because what is derivative of this function? This is 1 by n plus 1, constant comes out, then derivative of this will be n plus 1 into x to the power n plus 1 minus 1. So 1 gets cancelled and you are left with xn here, and this n plus 1 gets cancelled. So you are left with xn. So derivative of this is this. So integral of this is this. And when n is equal to minus 1, that is when you have 1 by x. Then what is this integral? Log x, or we say log mod x. And I often do not write constant here. Don't forget to put this constant term here. Okay, so log mod x plus c, because derivative of log x is 1 by x. Derivative of ax is ax log a. So integral of ax will be ax divided by log a, because when you will be differentiating now, you will have 1 by log a. Derivative of this will be ax log a. Okay, so log a gets cancelled and we are left with ax. So derivative of this term is ax. So integral of ax is this. Okay, so in this way, please scroll it down. So integral of exponential x is exponential x only. Derivative of cos x is minus sin x. Thus, integral of minus sin x is cos x, or you can say integral of sin x is cos x. Likewise, integral of cos x is sin x. Integral of secant square x is 10x, because derivative of 10x is secant square x. Derivative of cot x is minus cosecant square x. Thus, integral of cosecant square x is minus cot x. Then derivative of sine inverse x is, what is derivative of this function? 1 upon under root 1 minus x square. Thus, integral of this is sine inverse x plus constant, right? And what is derivative of cos inverse x? That is minus 1 upon this, right? So you may also say that integral of this is minus of cos inverse x plus c. And I am also writing here that this integral is sine inverse x plus c. So do you think I am saying that sine inverse x is equal to minus cos inverse x? No, it doesn't mean that. What is the relationship between sine inverse x and cos inverse x? Their sum is pi by 2. So sine inverse x is actually, or you can say cos inverse x is pi by 2 minus sine inverse x. So if you put here this term minus cos inverse x is pi by minus pi by 2 plus sine inverse x. So that pi by 2 or minus pi by 2 has been taken in this term, constant term here. Okay, so we do here these constants are not same. Okay, so I am not saying that cos inverse x is same as sine inverse x. And then integral of secant x tan x is sec x. Integral of cosecant x cot x is minus cosecant x, you know that. And integral of 1 upon 1 plus x square is tan inverse x, because derivative of tan inverse x is 1 upon 1 plus x square. Next page, please. Okay, likewise, integral of 1 upon x into under root x square minus 1 dx is secant inverse x. So that you know, and you need to remember these formulas daily, because these will be helpful in finding integral of other functions. Okay, then we have algebra of integration, which says that sum of two integrable functions is also integrable, and the integral of the sum is integral f1 plus integral f2. If I am only writing this, it means that I am assuming that I am integrating with respect to x or whatever the variable of function f is. Okay, and integral of constant time any function is k constant time integral fx. Okay, and similarly we have for difference. Okay, so this is algebra of integration. So if you have if you know integral of cosine x sin x, then you know integral of this function as well now. Okay, so in this way we have many more integrable functions. Next, scroll it down. Now let's discuss some methods of integration. Broadly, they can be classified in these 4 categories: integration using simple formulae, integration by substitution, integration by parts, and integration by partial fraction. In today's session, we will discuss first 2 forms, okay, and next 2 we will discuss in next session. Okay, so now integration using simple formula. Here you can directly find the integral by inspection. Okay, if you can find it by inspection only, it will save you a lot of time. Okay, so practice doing such integration, and then you may involve you may have to factorize it or doing some simplifications. Okay, so let's do some examples. So what is this first expression? I have to evaluate this integral. 2 to the power 5 log base 2x minus 3 to the power 4 log 3x upon e to the power 3 log ex minus 10 to the power 2 log 10x dx. So this is looking such a complicated expression. How will you proceed? Any guesses? Seems a complicated expression, but let me tell you, this is very simple problem. Yes. So you can write this as, you can take this 5 here in power. So this is 2 log 2 x to the power 5 minus 3 log base 3 x to the power 4 upon exponential log with base e x to the power 3 minus 10 log with base 10 x square, right? And then you know
e to the power x.
this base, when these are same, you have this, you are left out with this expression only. Okay, so this is x to the power 5 minus x to the power 4 over x cube minus x square. So I'm left with x upon take out x common, x to the power 4 common, x minus 1 over x square, x minus 1, x minus 1, x minus 1 gets cancelled. So integral x square dx. Okay, so such a complicated expression it was, but just simplifying, we have obtained this. And now we know using standard formula that this is x cube by 3 plus a constant. Okay. Also, it may happen that you are able to integrate a function, but the options you are given, you will not be able to find your expression there. Okay, because that expression may be given in some different form there. Okay, so sometimes even looking at the options, you will get some hint how to proceed. We will, don't worry, we will be doing such problems. Next, please. Next. Yes. So integral x sin x plus cos x upon x square dx. What do you think? You may just begin with the rules you have learned for sine and cos, taking something common. But if you look this expression carefully, then what is it? It is
X sin x over x square plus integration of cos x over x square.
okay. Then see how long it takes.
Sin x upon x side.
Can you recognize this expression with derivative of something? Is it looking like quotient rule of something? See, you have x square. Okay, so if you have in denominator x, then derivative of this x square, you have denominator as it is, then this must be derivative of your numerator. So sin x is derivative of cos x. So this is actually x derivative of cos x minus sine as well, right? Because derivative of cos is sine, plus derivative of x into cos x. So I can write this as minus x dash into minus cos x, right? So what is this thing? This is derivative of minus cos x upon x. Okay, so this function is derivative of minus cos x by x. So integral of this is minus cos x by x plus c. Sin x by x is not integrable, but sin x by x into if you have something, that may change the nature. Suppose you have into x, so it gets cancelled out. Okay? Yes? Okay, what I just said about sin x. Solution. Okay. When I look at this expression carefully, I can recognize it as that it is something of the form quotient rule. Okay, why? Because it clicked to me, because in denominator I am having x square of some function. In numerator I am having that function as it is. Okay, so if this is derivative of some rational function, then what quotient rule says? What is derivative of f by g? It is f dash g minus g dash f over g square. So it seems that g is x. Fine. So here you have derivative of g dash, which is 1. Okay. And here you have g as it is x. So this thing should be derivative of f. So sin x is derivative of minus cos x. Okay, so this is actually x into derivative of minus cos x minus derivative of x into minus cos x upon x square. Okay, so this is derivative of minus cos x by x. So using definition only, I have that integral of this is minus cos x by x. Okay, obviously you will not recognize it at just first instance, but when you will practice such problems, so obviously it is saving your time. Okay, as you said that you may be trying by separating this and then you would do something, and then there is no guarantee whether it will be the solution or not. Okay, so next problem is integral fx f double dash x plus f dash x whole square into dx. Just give it a try. We just use quotient rule. Now, do you think that here you have something kind of product rule? So try it. So this function is as it is, then you have derivative of f dash x, right? And as I said, looking at the options given are false here. Okay, so fx into f dash x, derivative of this function plus derivative of this function into this as it is, right? Okay, so what is it? It is derivative of fx into f dash x. Okay, it's fine. So which option is correct? Option B. Okay, so next please. So in this problem, what we have? Integral of tan inverse sine 2x over 1 plus cos 2x dx, where x is between minus pi by 2 to pi by 2. When you have something of this expression, of this form, try to convert this thing as tangent of something, so that tan inverse and tan gets cancelled out. Okay, so here you can use trigonometric identities which you have learned in class 11th and 12th. So sine 2x is 2 sine x cos x, and here 2 cos square x minus 1 and 1 gets cancelled. Okay, so 2 gets cancelled with 2, cos x with cos x, so I am left with tan inverse tan x dx, which is integral x dx, which is x square by 2 plus constant. Okay, so directly using standard integral. Fine. So you may have such complicated expressions which on simplification just give you very basic expression. Okay. So with practice you will learn this. We will do more problems later on when you will have to identify on your own, because right now I am discussing problems topic wise. So that would be giving you certain hint that this problem can be tackled using this thing. Okay. So next method is, next please, which is the most important method I can say, because most of the time you are using this substitution method only. So what is this integration by substitution? Here you change your independent variable, the variable with respect to which you are integrating. You will change x to some other function of t, or some function of x to some function of t. Okay, so we will be basically today discussing in which form which substitution is helpful. Okay, so first thing is, when you have your integrand is of this form. In mathematical terms it may seem a hard expression, but when you will have problems you will identify on your own that it is of this form. So just tell me, if you have to integrate this thing and you have fx and derivative of this is present here, so what should be my substitution? If I put fx is equal to t, then differentiating both sides, first you differentiate this, then dx, this is equal to dt. So this expression becomes a simple expression, gt into dt. And if function g is integrable, suppose integral of g is h, then you substitute back the value of t, which is fx. Okay, so this will be helpful. So in particular, if I have, okay, clear? So in particular, if I have this expression, integral fx into f dash x dx. So basically what is my g function here? That is the function x. G of fx is fx. So what should be substitution here? Fx is equal to t. So I'm left with t, and this is dt. So this is t square by 2. So this is fx whole square by 2 plus a constant. Okay, so you can remember this formula. Next is, if you have expression of this form, fx f dash x upon fx dx. What is function g here? 1 by x. G of fx is 1 by fx. So gx is 1 by x. So here also, if you substitute fx is equal to t, f dash x dx is dt. So I'm left with 1 by t dt. So which is log t plus constant. So it is log of fx plus a constant. Okay, so using this formula, I have another set of formula now. Integral of 10x. See, 10x is not derivative of any function in a way of standard trigonometric functions, you know. So I can write 10x as sin x by cos x dx. What is derivative of cos? Minus, minus sine. So I can write this in this way. Fine. So derivative of this is present here. So what is this? Minus log of cos x. Okay. So you have this thing. And then if you take this minus sign here, using the property of log, what is cos x inverse? This is not cos inverse x. This is what? 1 upon cos x, which is sec x. Okay. So this is same as this thing. Okay. So in the options, you will be using such different forms in solving problems. Similarly, integral of cot x will be, cot x can be written as cos upon sine, where derivative of cos upon sine, derivative of sine x is cos x. So this is log sine x. Okay. Then integral of sec x. I can write it as sec x into sec x plus tan x upon, well, you need not to learn how you get this. You just need to remember the formula. Then what is this? Sec square x plus sec x tan x upon sec x plus tan x dx. Okay, now what is derivative of the denominator? Derivative of sec x is sec x tan x. Derivative of tan x is sec square x. So this is log of sec x plus tan x. Though you need to remember only this formula, but still, if you know how you get this expression, it will be easier for you to remember the formula. Because sometimes even I get confused, do I have negative sign here or not? Okay, so if you know how you have got this formula, it would be easier to you. Or if you forget sometime, then you can derive it on your own. Okay, similarly, you have integral of cosecant x dx is log of mod cosecant x minus cot x, or in this form, log mod tan x by 2, which you obtain using some trigonometric relationships. Then if you have something of this form, f of ax plus b dx. If I multiply this with a and divide it by a, see, this is also some function. Or let me write here g, the form which I was using. Then fx is actually ax plus b, and derivative of fx is a. Fine. So if I substitute this is equal to t, then what I have? 1 by a integral gt dt. Fine. If integral of g is ht, then I have this thing. And then you put back ax plus b. Okay. So all the formulas we have obtained so far, if you replace x there by ax plus b, on the right hand side, you will have to divide by a. Okay. So we have integral of ax plus b to the power n is, what is integral of xn? Xn plus 1 upon n plus 1. So integral of ax plus b to the power n will be ax plus b to the power n plus 1 upon n plus 1 into a. Into a is in denominator. Okay, for n not equal to minus 1. 1 upon ax plus b will be log of ax plus b upon a. Okay, so next please. So you have all these formulas, equivalent form of all these formulas. Sine, integral of sine x plus b will be next, minus cos x plus b by n, so on. Next page. Okay, then you have some special integration formula. These are really very helpful in solving problems. So let's look at this first formula, 1 upon under root a square minus x square dx. See, I know what is integral of 1 upon under root 1 minus x square. So if I take this a square outside, then from square root you will have just a. So 1 upon under root 1 minus x square by a square, which I can write like this. Fine. Now what is this? This is something of the form ax plus b, where a actually is 1 by a. So integral of this is sine inverse x by a, and then you have to divide the whole by 1 by a. 1 by a, and 1 by a here is as already So this gets cancelled. So you are left with sine inverse x by a plus c. Okay, similarly, you will have for cos inverse x by a, for tan inverse x by a. Just try to remember that in sine inverse under root a square minus x square, when you are using this sine inverse x by a, you do not have 1 by a. But in tan inverse, you will have. So just remember all these formulas. Okay, next. Okay. Then we have some special integrals, 1 upon under root x square minus a square. Do you remember this formula? I'm not going to prove it. Just recall these formula. Log of mod under root x square minus a square plus c. So this formula will be helpful. Likewise, you have for plus here, then you have plus here, then another is 1 upon x square minus a square dx. This is 1 by 2a log x minus a over x plus a, or x plus a over x minus a. Okay, good. Then if you remember all these, and similarly you have for this, okay, 1 by 2a log of x, a plus x over a minus x, right? I'm not telling you how you obtain this. You must have done that. And then scroll it down, please. Some more special integration formulas of this form. When you have this thing in numerator, this or this or this. So these are formula 11, 12 and 13. When you have these in numerator, you have two terms. First term involves x by 2 into exactly this expression. I have typed it wrong. That's a typos. So under root a square minus x square. Here you will have x by 2 under root x square minus a square, and here and x by 2 under root x square plus a square. Then plus a square by 2. Exception is just to remember these. In under root x square minus a square, you have minus a square by 2, right? And then you have the term which you get on integrating the function when you have this term in denominator. Okay, so under root 1 by a square minus x square, it has integral a sine inverse x by a. So you have that in the other term. In formula 11, you can see. Okay, in formula 12, you have log this expression because this is the integral of this. Okay, and likewise there. Next, please. So we will be using these formulas very often. Okay, so again, some problems using these formula. Previous page. Scroll it down. Okay, next page. Okay, this note. So when you have integrals of this form, when are these formulas applicable? When you have something under root a quadratic expression or 1 upon under root quadratic expression, what we will be doing, we will be completing the squares here. Okay, so first make the coefficient of x square unity. Okay, that is by taking a common from the whole. Okay, and then complete the squares. You know how to complete it. Square, add and subtract the square of the term, half of the term with x. We will do that, and then apply these special formulas. Next page. So suppose we have to integrate this function, right? So you have something 1 upon under root a quadratic expression. Okay, so what we do first, make the coefficient of x square unity. So I can write it as dx upon under root minus, take minus common, x square plus 4x minus 5. Okay, we cannot take this minus outside. Imaginary form. So then what we do, half it, so you get 2, square it, 4, so plus 4 and minus 4, so minus 5 is already there, so I have this thing. So integral dx upon under root 9 minus this, which is x plus 2 whole square. Okay, so and you can write this 9 as 3 square. So what is it? It is of the form dx upon under root a square minus ax plus b square. Fine. So what will be the solution? Sine inverse x plus 2 by 3 and then plus c. That's all. Sure. And what if I had here some, say 2? Then you would have 1 by 2. Okay. Okay. So the solution in this case is option B. Okay. Next. Now how to solve this problem? So first step is rationalizing it. Okay. So rationalize the denominator. This is same as x plus under root x square minus 1 upon x square minus square of this. So this is x plus under root x square minus 1 dx, right? So you know integral of x is x square by 2, and then this is special integral under root x square minus a square. So it is, first you have x by 2, this expression as it is, right? Then plus a square by 2. What is a here? 1. So minus, okay, it is that formula where we had exception. So minus 1 by 2 and then log of x plus under root x square minus 1. Okay, so which is option? This is option C. Where is half? 1 by 2 is, so it is D. Next. Okay, so now the main part of this lecture. Listen, these form, so when you have something of this form, integral 1 upon x into xn plus 1 dx, n is some positive integer, then what we do, we take this xn common. Okay, so sorry, so you will have x to the power n plus 1, 1 plus x to the power minus n, right? Now if you put this thing as some new variable t, then what is derivative of this? Minus n x to the power minus n minus 1 dx is equal to dt. That is minus n upon x to the power n plus 1 dx is dt, or you can take this here. Fine. So This we have substituted to be t, and dx upon this is dt upon minus n, right? Which is integrable. So this is minus 1 by n log t, and you substitute back t. So you have to remember this thing. When you have 1 upon x into xn plus 1, take xn common and then substitute this term as your new variable. Okay, remember this. Okay, next form is, so these are some substitutions. You do not need to remember how to proceed. So next is, no. Okay. So when you have something of this form, x square into xn plus 1 n minus 1 over n. Okay. When you have this thing, again, I take xn common. Okay. But this time, it will be x to the power n will get cancelled with this n. So x to the power n minus 1. And inside we are left with 1 plus x to the power minus n. Okay. And minus 1 upon n. So now what should be my substitution? Here this is again x to the power n plus 1. Fine. So again, if I put this term as this term as, if you substitute this as t, you will be still having n minus 1 upon n. Okay, so this n in denominator will be troubling you. So what we do, we put this as t to the power n. Okay, so that when you substitute t n here, n gets cancelled with this. Okay, so when you have this thing, differentiating both sides, you will have minus n x to the minus n upon x to the power n plus 1 dx is equal to nt n minus 1 dt. Okay, so this term will not be troubling you. Okay, this will be replaced by this upon, so this n gets cancelled. You take minus sign here. Okay, so this term will be replaced by this some function of t. This has also been replaced by t to the power n minus 1. Okay, you have t to the power n minus 1. It will be cancelled out and you will be able to solve this. Okay, so in first expression you had x and here 1. When you have 2 here, we are having n minus 1 by n, and then more general form, the third form, when we have n here and here I have 1 by n. Okay, again we take xn outside, so you have x to the power n plus 1 again. Okay, and inside 1 plus x to the power minus n 1 by n. So again, when you will be substituting this thing as some power, this term will not bother you because derivative of this will involve this term, this term. Okay, so what should be my substitution? Tell me. Why t to the power 1 by n? You have here 1 by n. So this to the power 1 by n should be t. So actually this should be t to the power n. Okay. That's why if you will just try to cram the formula, you will not be able to. Okay. Understand why we are doing this substitution. So why we are doing this substitution? Because derivative of this will give you this term. Okay. And this to the power 1 by n will be giving you t. Okay. So in these three forms, learn by heart what will be the substitution. Next, please. Okay. When your function involves x and something of the form a square minus x square, right? Then you know this identity. 1 minus sine square x is cos square x, or 1 minus cos square x is sine square x. Okay, so when you have a square minus x square, I should have something of this form will be helpful to me. Okay, so we usually substitute x is equal to a cos t or a sin t. Okay, this kind of substitution will be helpful. So when you have function x into x square minus a square, in such forms, you know this identity, secant square x minus 1 is tan square x, cosecant square x minus 1 is cot square x. Okay, so when you have something of this form, what should be my substitution? X is equal to a sec t or a cosecant t. Okay, next is when you have something of this form. So a square plus x square. Which kind of identity I should use here? 1 plus tan square t is equal to sec square t, or 1 plus cot square t is cosecant square t. So in such forms, we will be doing this substitution, a tan t or a cot t. Okay. So I'm telling you all this just to remember. Okay. This will help you in identifying which substitution you should make. So when you have something of this form, in such form, if you put x is equal to cos 2t, then you know 1 plus cos 2t can be expressed in terms of sine square of half of the angle, and here, sorry, here cos square and here sine square. So if you make this substitution, x is equal to cos t, then you will be having a into 1 plus a cos t. A cos t upon a 1 minus cos t. So a gets cancelled, under root 2 cos square t by 2 upon 2 sine square t by 2. So this gets cancelled. You have under root cot square t by 2. So you are left out something of this form which you can integrate. Okay, so in such form, either a cos t or a cos 2t, because that is also going to give you similar form. When you have, so any question? So when you have something of this form, under root x minus a over x minus b. Here you have 1 plus 1 minus. Okay, and x was in negative term. Here x minus a upon x minus b. Whether you have this form or this form. Then the substitution is, you will have to learn this, but how this help you, that I will tell you. So when you substitute x is equal to this, okay, so in integration you will have to remember so many formula. So daily make it a habit looking at these formula and practicing problems. So when you do this substitution, what you will have? Under root a sec square t minus b tan square t minus a upon a sec square t minus b tan square t minus b. So when you, what is this? When you take a common, sec square t minus 1 will be tan square t minus b tan square t. And here you collect these two terms because b can be taken outside. A sec square t minus b 1 plus tan square t is, okay, then you can take tan square t common. So you are left with a minus b. Here you can take secant squared t common. You are left with a minus b. This gets cancelled and you are left with tan t over sec t. Okay, when you change it to cos and sine thing, you will easily be able to integrate. Okay, then similarly, when you have under root x minus a and b minus x. In previous expression, you had x minus b. Now, when you have b minus x, this substitution, x is equal to a cos square t plus b sine square t. Okay, you will have similar sort of steps. Okay, so this substitution will be helpful. And when your integrand have expressions of this form, then if you put x is equal to 2a sine square t, then this will become 2a into 2a, so 4a square sine square t minus, when you square it, 4a square sine 4t. So 4a square can be taken outside. Sine square t you can take common, 1 minus sine square t. 1 minus sine square t is cos square t. So you have 2a sine t cos t or a sine 2t, which you know how to integrate. Okay, and when your integrate, similarly integrand contains terms of the form under root a square minus x square under root a square plus x square, then this substitution x square is equal to cos 2t is helpful. Next please. Okay, so let's do this problem. So I have to integrate x to the power 3m plus x to the power 2m plus x to the power m into 2 to the power 2x to the power 2m plus 3x to the power m plus 6 to the power 1 by m dx. So what do you think? Some kind of substitution should be there. Immediately it may strike to you, take xm common. Maybe, I don't know. So if you take xm common, you are left with x to the power 2m plus x to the power m plus 1. Now here you have this. Do you think this is going to help me? These if coefficients had been similar, then it might have been helpful to me. But here there is no relationship, so this is not going to help. Okay. Okay. Now here, if you have 3m here, if you multiply this whole expression with x to the power m, then you will have 2x 3m plus 3x 2m plus 6m, right? Now when you will be substituting this thing as t, then you will have 6m x to the power 3m minus 1 plus 6m x to the power 2m minus 1 plus 6m x to the power m minus 1. So this 6m can be taken common and you may have something of this form. Okay, if you directly substitute this thing as t, you will have 4m here, 3m here, 6. Okay, in no way you will be able to obtain this thing, something of this form. So as I said earlier, you will learn this only with practice. So what should I do? I should multiply this expression with x to the power m. So actually I am multiplying the whole function with x, because when you multiply it with x, inside it will go as x to the power m. So I multiply and divide by x. So what I have? X to the power 3m plus x to the power 2m plus x to the power m by x into 2x to the power 2m plus m. Okay, so 3m plus 3x to the power 2m plus 6x to the power m 1 by m dx. Now when you substitute this thing is equal to t, then as we observed, taking 6m outside, we were left with x to the power 3m minus 1 plus x to the power 2m minus 1 plus x to the power m minus 1. This dx is equal to dt. Fine. Now here if you divide this whole with x, what you have? 3m minus 1, 2m minus 1, this. Okay? Which is exactly this expression. Okay? So the value of this thing is dt by 6m. Okay? So with this substitution, this thing is equal to t. This integrand becomes 1 by 6m, 1 by 6m. Answer is C only. Don't jump to the conclusion so fast. So this is t to the power 1 by m dt. Okay, so which is t to the power 1 by m plus 1 upon 1 by m plus 1. Now when you simplify this, you will have m plus 1 upon m. So m gets cancelled. Okay, so you have 1 upon 6m plus 1, 6 into m plus 1 into this expression to the power 1 by m plus 1, which is 1 by m plus 1. Okay, then again typos. So you should have 1 by m plus 1 in option C, or in option B you should have 1 upon 6 into m plus 1. In this situation it is none of this. Okay, that's just a typing error. I should have here plus 1. Okay, so next is integral x under root a square minus x square upon a square plus x square. Tell me, what should be the substitution? See, if you look at this thing here, this is x and you have x square. So you can first simplify this expression by substituting x square is equal to t. Okay, so first substitution is x square is equal to t. So that 2x dx is dt, or x dx is dt by 2. So this is 1 by 2 under root a square minus t upon a square plus t dt. Now you look at that form. So it is something of, say this is another constant c, something of the form under root c minus t upon c plus t. So what should be substitution? Cos 2t or okay, cos 2z or cos z, anything. Okay, so tell me which one should I use? Cos t. So t is equal to, don't forget to put a. So a cos theta. You may have cos 2 theta as well. Okay, both will give you the same form. Later on when you will be substituting the value back, that will depend on that. So t is equal to a cos theta. So dt is equal to minus a sin theta d theta. So what I have? 1 by 2 under root a square. It should be a square. Okay, because then only you will be able to take out a square common. So a square 1 minus cos theta upon a square 1 plus cos theta, and dt is minus a square sin theta d theta. Okay, so this is minus a square by 2 under root 1 minus cos theta is 2 sin square theta by 2 upon 2 cos square theta by 2 into sin theta d theta. So you have minus a square by 2 integral sin theta by 2 cos theta by 2 into sin theta d theta. Now you have something in terms of theta by 2, something in terms of theta. So I should use sin 2 theta is equal to 2 sin theta cos theta. So this identity gives me 2 sin theta by 2 cos theta by 2. This gets cancelled. This 2 gets cancelled. So we are left with minus a square integral sin square theta by 2 d theta. When you have something of this form, sin mx, you use trigonometric relations to convert it to cos of multiple. So again, 1 minus cos theta by 2. Okay, so this integral of this, so minus a square by 2 integral of 1 and integral of cos theta. Okay, so what I have, minus a square by 2 theta minus cos theta is integral of, so minus sin theta plus c. Derivative of sin is cos, so integral of cos is sin. Okay, okay, so now substitute back the values. So you have minus a square by 2 theta was cos t, a square cos t. uh, my substitution was a square cos t cos theta is equal to t. This was my substitution. So from here I need to evaluate what theta is. So cos theta is t by a square. So theta is cos inverse t by a square. Okay, and t was x square, because original question is in terms of x. So we have this cos inverse x square by a square minus minus plus a square by 2 sin theta, and theta is cos inverse x square by a square plus c. Now if you have to just integrate, you may leave your answer in this form, but we have to identify which option it is. So is any of the option in this form? You do not have sine, cos, inverse. You don't. So use some relationship here. We have this relationship, sine of cos inverse x is under root 1 minus x square. Okay, so using this relationship, you will have here minus a square by 2 cos inverse x square by a square plus a square by 2. This will be under root 1 minus square of this whole. So x4 over a4. Okay, so this is A4 by X4 upon A4, then A4 you, when it comes out, you will have this or this. Okay, so minus A square by 2 cos inverse X square by A square plus 1 by 2 under root A4 minus X4 plus C. Do we have such option? Slide, please. So this is option B. Okay, so now you know this relationship. Cos inverse X is same as pi by 2 minus sine inverse X. So this is also same as pi by 2 minus sine inverse X square by A square plus 1 by 2 under root A4 minus X4 plus C. Now this term is a constant. You can take it in this C, fine. And minus into minus, you will have plus. So this option is also correct. So it may happen that this option is given in the solution and the previous one is not. Fine. So that's why I told you in the beginning, you have to be extra careful in marking your option. It may be that you have found the correct answer, but then you mark it wrong. Okay, don't do that. Next, please. Okay, so what should be substitution in this problem? 1 upon x square x4 plus 1 to the power 3 by 4. Can you identify with any of the three integrals we discussed? Second one, n here is 4, so n minus 1 is 3 by 4. So what should be the substitution? You take this x4 common first. So 1 upon x square, you will have x only, x cube. Okay, and 1 plus x to the 1 by x4 to the power 3 by 4 dx. So what should be my substitution? Put 1 plus 1 by x4 is equal to t. So you will have minus 4 by x5 dx is equal to dt, right? So multiply this with minus 4 and divide by minus 4. So this thing is dt. And here you have, this should be the substitution. This should be equal to t to the power 4. So 4t cube dt. So 4t cube dt upon t cube. T cube. Okay, because t to the power 4, 4 gets cancelled. So what I have? Minus t plus c. T is 1 plus 1 by x4 to the power 1 by 4 plus c. So the question is in this form. What is k? So what is k? What is the mistake here? Somewhere we have done mistake. This is equal to t to the power 4, 4t cube dt. Or maybe that's a typing error. That must have been 1 by 4. So option A is correct. Okay. So many typing errors I have done this time. Okay, next. Okay, this question has been asked in exam. So let fx is equal to x upon 1 plus x to the power n to the power 1 by n for n greater than equal to 2. And gx is composition of f n times Okay, then what we have to evaluate the value of x to the power n minus 2 into gx. Okay, so first step is we have to evaluate what is gx. Okay, then only you can integrate this. So what is gx? Composition and time. So let's see what is FOF at x. So what is f of fx? This is f of fx. Fx is this. So f of fx this fx upon 1 plus, replace x by fx, this to the power n, this to the power 1 by n. Now substitute the value of fx. So fx is x upon 1 plus xn to the power 1 by n, 1 plus fx to the power n. So this to the power n will give me xn over 1 plus xn. This 1 by n gets cancelled. Okay. And this to the power 1 by n. So when you simplify it, 1 upon 1 plus xn to the power 1 by n over, taking LCM, you will have 1 plus xn, that makes it 2xn to the power 1 by n upon 1 plus xn to the power 1 by n. So this gets cancelled and we have x upon 1 plus 2xn to the power 1 by n. So fx is this. The only difference we have got in f of f is here you have 2. Similarly, you can check when you will be taking f of f, you will have here 3. Okay, you can check that. So generalizing this, what is gx? Gx will be x upon 1 plus nxn to the power 1 by n. Okay, so integral xn minus 2 gx dx will be integral x to the power n minus 2 plus 1. So n minus 1 upon 1 plus nxn to the power 1 by n. Now can you tell me what should be the substitution? See, when you substitute this thing, you will have something x to the power n minus 1 which is present here. Okay, so substitution could be 1 plus n x to the power n, this is equal to t. So that you have n square into x to the power n minus 1 dx is equal to dt. So this becomes, or you multiply with and divide with n square. So 1 by n square, this is dt over, this expression is t to the power 1 by n. So t to the power minus 1 by n, integral will be t to the power minus 1 by n plus 1 over minus 1 by n plus 1 plus c. Okay, and then you have 1 upon n square. So you can simplify it, substitute the value of t back and you will get the solution. Okay, next please. Okay, so if fx is integral x plus 1 under root x plus 2 over x minus 2. We did not have any substitution for this form under root x plus a upon x minus a. We had for a minus x, but not for x minus a. So don't think about the those kind of substitutions. So we are, only option we are left with is rationalizing. Okay, so rationalizing, you will have x plus 1. So in denominator, you will have x square minus 4. And here you will have under root x plus 2 square. So which makes it this. So when you solve this, you will have x square plus 3x plus 2. In this problem, if you look at the options, you will get some idea what should be my substitution. So when you have something of this form, try to break this fraction, make it in some 2 terms or 3 terms, which can be integrated. So if I have here -4, if I have -4 with this term, then x square minus 4 upon root this can be tackled. Okay. So what I do, I add and subtract 4. So x square minus 4 plus 4, that makes it 6. So this can be break down as x square minus 4 upon x square minus 4 plus 3x plus 6 upon under root x square minus 4. Now this will be under root x square minus 4, which can be integrated. Now here the derivative of x square minus 4 will be 2x. So if I break even these terms, this can be integrated using special formula. And here if you substitute, this is equal to t. Substitute x square minus 4 is equal to t, then you are left with 2x dx is equal to dt. So 3 by 2 into 2x. So you will have 3 by 2 into 2x dx will be dt upon under root t, which can be integrated. Okay, so integrating these 3 terms and then substituting the value back and simplifying, you will get the correct answer. Next, please. So just to save time, I am not doing. Okay, you will have any of these options. Then next, when we have integrals of this form, sine mx cos nx dx. When here, if m is odd and n is even, then substitute even one. Cos x is equal to t. Why? Because if you have something of this form, say sine square x cos cube x dx, when you put sine x is equal to t, derivative of that will be cos x. So from here you can separate it. Okay, so cos x dx will be dt, sine square x will be t square. Okay, and this can be converted in terms of sine square. Okay, so this kind of thing can be easily handled. Similarly, if n is odd and m is even, then sine x should be the substitution. And if both m and n are odd, you can put anyone as cos t, but usually if you take the term with greater power as t, that might be helpful, but anyone will work. And if both m and n are even, if both are even, okay, even positive integers, then you convert sin mx and cos mx in terms of multiples of cos x, cos mx and cos nx using trigonometric identities. Okay, we will be doing such problems. And when, this is the special one, when m plus n is negative even integer, this is something of this form. Okay, where n is 2p, p is in n. When you have negative even integer, in that case, this substitution 10x is equal to t will be helpful. Can you show that, please? Okay, then tan x is equal to t or cot x is equal to t will be helpful. How we will be using it, I will show you in problems. Then we have integrals of this form, dx upon a plus b cos square x, a plus b sin square x. So you have square of with x cos x or with sin x or with both. Okay, or a sin x plus b cos x whole square. But each expression involves square. Fine. In this case, we multiply the numerator and denominator by secant square x, or you can say divide the numerator and denominator by cos square x. And then, so suppose when you have expression of this form, a plus b cos square x. So if you divide the numerator and denominator by cos square x, what you will have? Sec square x here. Okay. Then a sec square x plus 1. Fine. If you put tan x is equal to t, secant square x dx will be dt. This can be converted in terms of tan x. Okay. So it will be simplified then, and similarly in others. Okay. So when each is in square term, when you have here when you will be opening it, a square sine square x plus b square cos square x plus 2ab sin x cos x. So again you have degree 2. Okay, when each term is having is of degree 1, a plus b cos x or a plus b sin x or a sin x plus b sin x cos x plus c. Okay, in this situation this substitution will be helpful. Sin x is equal to 2 tan x by 2 upon 1 plus tan square x by 2, and cos x is equal to 1 minus tan square x by 2 upon 1 plus tan square x by 2. And then we will be substituting tan x by 2 is equal to t. So the whole expression will reduce to some function of tan x by 2. Okay, next please. When you have integral of this form, in numerator and denominator you have expressions in involving sin x cos x. Okay, in this case we factorize this expression in some of uh, a few terms which individually can be tackled. So the formula to remember this is, you put numerator is equal to some constant times denominator plus another constant times derivative of denominator. Okay, and plus a constant. Okay, so that when you substitute this thing, and then what you do, you compare the like terms and you evaluate a, b and c, so that when you put this value in the expression, what you will have, you have something of this form. Okay, so when you divide this with dr, you are left with a which can be integrated. When you divide it with dr, you have some function, and in numerator you have denominator derivative of this, so this can be handled. And when you have c upon dr, where you know how to tackle this term 1 upon dr. This is just the previous form. Okay, so in this way you can solve it. Next, so integral of this form, a plus b cos x upon b plus a cos x. So coefficients have been interchanged. Okay, so when you have a plus b cos x upon b plus a cos x square, we divide the numerator and denominator by sine square x. And when you have a plus b sin x upon b plus a sin x whole square, we divide the numerator and denominator with cos square x. Okay, let's do some problems now. So integral sin x. So is this in the form sin mx cos nx? Yes, it is. Take these terms in numerator. So you will have sin minus 1x, or or take sin x to the power minus 1, cos cube x to the power minus 3. So m plus n is a negative even integer, right? So what should be substitution? Tan x is equal to t. And what should I do? First I should multiply and divide. Either you said divide numerator and denominator by cos x. Okay, so what we have, 1 by cos square x, if you remember the form. Oh, okay, sorry, this is another form. Okay, so you have to convert this in some form of tan. So if I divide this with cos x and multiply with cos x, so this becomes 1 upon tan x, and this cos 4x becomes secant 4x dx. Okay, this tan x is t, so secant square x dx will be dt, and you are left with sec square x, which can be expressed as 1 plus tan square x. So I have actually this form. So put tan x is equal to t, so this becomes 1 plus t square dt upon t. So this is 1 by t plus t dt. So log t plus t square by 2. Substitute t is equal to tan x back. Okay, so you will have some of this option. Okay, simplifying. Next, please. Now here, when you have secant square x cosecant 4x, when you, this can also be brought in the form some power of sine and cos. Okay, so this is actually 1 by sine 4x and cos square x. So again, m plus n is negative even integer. So similarly, you can solve it. So when you will solve it, because we are running short of time, when you will solve it, you will have some term with cot cube x, okay, some constant with tan x, some constant with cot x, okay. So solving, you can find, comparing the terms, you will get k is equal to minus 1 by 3 and m is equal to minus 2. L will turn out to be 1 or minus 1 as far as I remember, okay. So next please. Okay, if I is equal to integral sine 4x upon sine 4x plus cos 4x dx. Hmm? This does not belong to any category. But powers of sine and cos are even. Okay, so when powers are even, we know we change sine and cos to multiple of cos. Okay, powers of sine to, we discuss this form. When both powers are even, we use this relationship. Sine square x is equal to 1 plus 1 minus cos 2x by 2 and cos square x is equal to 1 plus cos 2x by 2. Okay, so let's see if such substitution is, not substitution, such transformation is helpful to me or not. So this is sine square x whole square, okay, and this is sine square x whole square plus cos square x whole square. I'm not saying this is the unique way, as I said earlier as well. There are several possible methods. So this is what? 1 minus cos 2x by 2 whole square upon 1 minus cos 2x by 2 whole square plus 1 plus cos 2x by 2 whole square dx. So when you will be taking the square, this 2 will get cancelled. And 1 plus cos square 2x minus 2 cos 2x upon a minus b square plus a plus b whole square is twice of a square plus b square. So twice of 1 plus cos square 2x. Now if you look at this expression carefully, we can write it as this upon this will be 1 by 2 and minus integral cos 2x upon 1 plus cos square 2x. This you know is x. How to solve this expression? I have here cos 2x, which is derivative of sine 2x. So if I have something here in terms of sine 2x, that would be helpful to me. So obviously I can convert cos square x to sine square x with the identity cos square x plus sine square x is equal to 1. So this is 1 minus sine square 2x. So 1 plus 1. So this is actually 2 minus 2 sine square 2x. Now substitute sine 2x is equal to t. So that 2 cos 2x dx is dt. So multiply and divide by 2. So what is this? Minus 1 by 2 integral. This is derivative of t upon 2 minus 2 t square. Okay. So then you know how to integrate this. This is special formula, 1 upon 1 minus t square. Okay. Some involved in log 1 upon a square minus x square form. Okay. So this can be tackled. Next problem. Okay, we will do this problem tomorrow maybe. Next, this problem 14th. So this is of the form a plus b cos x upon b plus a cos x whole square. So what was the working rule? Divide numerator and denominator with sine square x. So when this becomes 3 cos x square x plus 2 cos x by sin x will be cot x into cosec x upon, now when you will be dividing this with sine square x, you have square here, so inside you will have only sin x. So 2 cosec x plus 3 cot x, this square. Now what is derivative of this? 2 cot x cosecant x with minus sign. Okay, so if I write this in this form, then numerator is the derivative of this expression. Okay, so with this substitution, this becomes minus, this is equal to t, so 1 by t square, and this is dt. Okay, and then you substitute the value of t back. Next. Okay, integral of this form, x square plus minus a square divided by x4 plus kx square plus a4. So in numerator you have a square, the constant is a square, and denominator you have the square of that a4. Okay, and all terms are even. You have quadratic upon biquadratic, but all terms are even, no odd degree term is involved. Okay, in this form we divide the numerator and denominator by x square. So suppose I have x square plus a square upon x4 plus kx square plus a4. So dividing with x square will give me 1 plus a square by x square upon x square plus k plus a4 by x square. Okay, then I can write it as this. Fine. Then this term can be converted in, you can complete this square. You can write it as x plus a square by x whole square something minus something, or x minus this square plus something. Okay, we will do one problem. So if you have plus sign in numerator, then you convert it to this form, x minus something upon this. Okay, because derivative of this is what? 1 minus a square, and this will give you plus 1 by x square, which is in the numerator. And if you have minus here, then you convert it to this form. Okay, and then you substitute x plus a square by x as t. Okay, so we will do one problem. So you have this thing. So you have 3, and in denominator you have 9. If you do not have 9, you cannot apply this form. Okay, so don't waste time then. So x square minus 3. So dividing with x square, you have 1 minus 3 by x square upon x square plus 9 by x square plus 2. Okay, so I have to convert it in the form, this is x 3 by x whole square. Okay, so I want to make it something of the form x plus 3 by x square. Okay, so what should I add and subtract? If this is a, this is b, you have to add and subtract twice of ab. So twice of ab is 6. So plus 6 and minus 6. So minus 6 plus 2 makes it minus 4. So this term becomes x plus 3 by x whole square, okay, minus 4. So you have this thing. So substitute x plus 3 by x is equal to t. So that 1 minus 3 by x square dx is dt. Okay, so this becomes dt over t square minus 2 square. So which is special form. So you can solve it. Next. Okay, and then you can substitute the value of t back. Next form is integral of this form. X plus b over x plus a. This has some rational power, and dx upon x plus a whole square. You have here x plus a in denominator, okay, and then some rational power and square of this. Now if here you substitute x plus b by x plus a is equal to t, then in order to find its derivative, apply quotient rule. So derivative of this will be 1 into x plus a minus derivative of this 1 into x plus b over x plus a whole square. Dx is equal to dt. So this x gets cancelled. A minus b upon x plus a whole square dx is equal to dt, and you can take this here. Okay, so this is now t. Okay, and this is dt upon a minus b. So this can be solved. Okay, next problem please. Now the given expression may not be directly of this form. You may have to bring it in this form. So this problem is no. Next, dx upon x plus 1 to the power 6 by 5 x minus 3 to the power 4 by 5. Okay, so since I have something x plus a, x minus a form, okay, so I try to bring it in this form. So what should I do? Divide by x minus 3 to the power this and multiply with this, or I can do the same thing for this. You divide by x plus 1 to the power 4 by 5 and multiply with the same. Let's see what it becomes. Which one should I try? You can work with anyone. Okay, so let's do x plus 1 to the power 6 by 5 upon x minus 3 to the power 6 by 5, and when I multiply with this, what I get? 6 by 5 plus 4 by 5, 10 by 5, so which is 2. Okay, so when you add these powers, this is giving you square, so it may click to you that it can be bring in that form. Okay, so this is dx upon x plus 1 by x minus 3 to the power 6 by 5 and x minus 3 square. So what should be the form? X plus 1 upon x minus 3 to the power something. So this is actually x plus 1 upon x minus 3 to the power minus 6 by 5. Okay, so this is my p by q. So what is the substitution? Put x plus 1 upon x minus 3 is equal to t. So we will get what is the derivative? X minus 3 minus x minus 1 over x minus 3 whole square dx is equal to dt. So minus 4. So dx upon x minus 3 whole square is equal to minus 1 by 4 dt. So this is minus 1 by 4 integral t to the power minus 6 by 5 dt. Okay, and then you can solve this t to the power minus 6 by 5 plus 1 upon this and substitute the value of t back. And if you could have worked with this expression as well, same result you would have obtained. Next. Okay, when we have expressions of this form, integral p under root q dx or p by q dx or pq dx or p by root q dx. Okay, if both p and q, these are polynomial functions, if both are linear, okay, linear under root linear expression. So linear polynomial will be something of the form px plus q under root ax plus b, or the product of that, or p by under root ax plus b. In this form, you express px plus b as a times, this is my px plus b, and inside q is a px plus q and ax plus b probably I had taken. So put px plus q is equal to a times ax plus b plus a constant. Okay, and then solving for equating the like terms, you will find a and c. Okay, uh, so a will be p by a. Okay, a will be p by a and c will be, which I had taken b there, will you will get q minus pb by a. Okay, so when you will be substituting px plus q is equal to this thing, you will be left out with in this form only in terms of q. Okay, under root a quadratic expression or something which can be easily solved. We'll discuss some examples for that. Okay, then if you have p is linear and q is quadratic, which is second form, then you equate px plus q is equal to a times derivative of this, your quadratic expression. How to remember this thing? Your degree should be the same. When you have linear and linear, okay, you directly compare this with constant times the function, linear expressions on both sides. When you have linear here and quadratic here, derivative of this quadratic will be linear. So this is how you can just remember this. Okay, and when both are quadratic, when both are quadratic, then we put px plus q, px square plus qx plus r, or p is equal to a times q first, then b times derivative of q, okay, plus c, and then comparing you can find a, b, c. So in this way your problem will be reduced to much simpler form. Let's do one problem next day. There was one problem, I guess, on the previous slide. Scroll it down. Okay, so you have x plus 3 upon under root 4x square plus 4x minus 3. Okay, the first thing that will come to your mind is that if you can factorize it and do something, you can check that. It will not be easy. So you can use this form, linear upon root quadratic. So what is the formula? Equate x plus 3 is equal to derivative of this. So a times q air is this. Okay, so derivative of this is 8x plus 4 plus b. So equate the like terms. A into 8 is equal to 1 and 4a plus b is 3. So a becomes 1 by 8 and b becomes 3 minus 4 by 8. So 3 minus half, 5 by 2. Okay, so this expression becomes x plus 3 can be written in this form, 1 by 8 this plus 5 by 2. So this can be written as 1 by 8, 8x plus 4 upon under root 4x square plus 4x minus 3 plus 5 by 2 integral 1 upon under root 4x square plus 4x minus 3. Okay, so in this you would have tried to separate these terms only, right? So that task has been done with this working rule. Okay, when you substitute this is equal to t, derivative of this is here. So this expression can be handled. Okay, and here you know how to deal with quadratic expressions, completing the square and this. Okay, next. Previous slide, scroll that down, probably there is something. Okay, the next. So when you have next page then. No, previous. Scroll it down. No, above only. No. Scroll it up. Sorry. Okay, so integrals of this form dx upon px plus q under root. So now p under root q, or so you have integrand is of this form 1 by p under root q, where p is linear, q is also linear, okay, or p is quadratic, and basically q is linear and p is linear or quadratic. Okay, so put q is equal to t square. Okay, so that you get rid of this square root term. Okay, when integral is of this form 1 upon px plus q to the power n and under root quadratic, then this substitution px plus q is equal to 1 by t will be helpful. You will have to memorize these results. Okay, and when you have integral of this form dx upon quadratic root quadratic, then this substitution, the quadratic in the numerator is the one which is inside the root, okay, upon the previous one. This is equal to t square. Scroll it down. Okay, this one is important form. Understand this carefully. When your expression is of this form, this is in fact generalization of the first three rules we discussed, 1 upon x into 1 plus x and something. Okay, this is the most generalized form. So here you have x to the power m into a plus b x to the power n raised to the power p dx. If p is positive integer, okay, if p is positive, then you can expand this thing, okay, and you will have xm and positive thing, you will be able to integrate, you know how to integrate positive powers of x. When p is some rational of the form alpha by beta, if this is negative number, okay, then take this negative sign in alpha. Okay, if this is of the form alpha by beta, then you compute m plus 1 by n. Okay, m is the power of x, you compute m plus 1 by n. If this turns out to be an integer, okay, if this turns out to be an integer, then you substitute a plus b xn as t to the power beta, where what is beta? Beta is the denominator of this rational. Okay, if you have negative sign here, p is negative, take beta to be only the positive value. Okay, so and if m plus 1 by n is not an integer, okay, then what we do, we add p to it. This is a rational. It might happen that this rational added to this rational gives you integer. Okay, if this is the case, if m plus 1 by n plus p is integer, okay, then what we do, we put a plus b xn is equal to x to the power n t to the power beta. Okay, xn, n is what? This power, and beta is again the denominator of this rational. Okay, let's use this. Okay, and this is another one when you have integral some mth degree polynomial divided by root quadratic. Okay, then we'll do it tomorrow. Let's leave it. Then next, so integral dx upon x under root 1 minus x cube. Okay, so this is x 1 minus x cube to the power 1 by 2. Is it of any of the previous forms? It's not. When you had x and xn here, you had 1 here. So it does not belong to that form. Okay. So m here is, this is actually x minus 1, 1 minus x cube to the power minus half. So what is m here? Minus 1. Okay. What is n here? 3. And what is p here? Minus half. Okay. So you compute m plus 1 by n. So minus 1 plus 1 by n is 0, an integer. So what should be my substitution? Ax plus b as t to the power beta, where what is, no, what was substitution? Can you scroll it up? Okay, down. So it is a plus bxn is equal to 2 to the power beta. Okay, it was correct. So what is beta here? 2. Okay, this should be my substitution. So 1 minus differentiated, what you have, minus 3 x square dx is equal to 2t dt. But I have to find the value of dx by x. This will not be bothering me. Okay, so I have to compute dx by x. So divide both sides with x. So this is giving me actually dx is equal to minus 2 by 3 t dt by x square, and when you divide with x you will have x cube here. Okay, so dx by x is minus 2 by 3 t by x cube, and what is x cube? 1 minus t square. Correct? Please check all the calculations. Okay, so this is the thing. So this reduces to integral dx by x is minus 2 by 3 t over 1 minus t square dt, and this becomes 1 minus x cube is t square. So this is t. Okay, so this is minus 2 by 3 sine inverse t. Okay, and substitute the value of t back, under root 1 minus x cube. Okay, so this formula is really helpful. Next slide, please. Problem 19th. So see, such complicated expression. It is, I don't know if it is square root. Okay, square root x upon 1 plus x to the power. So square root x only, right? Sure. No. That's here. Okay. So it is this. So x to the power half, and this is 1 plus x to the power 3 by 4 to the power minus 1. So again of the same family. So m here is 1 by 2, n here is 3 by 4, p here is minus 1. P is not a positive integer, first of all. Okay, so m plus 1 by n. So half plus 1 by 3 by 4. So what I have, 3 by 2 by 3 by 4. So 2. So again, problem of the same type. So what should be my substitution? 1 plus a plus xb is equal to t to the power Beta. What is beta now? Denominator of p, it is 1. So this substitution will be helpful. So 1 plus x to the power 3 by 4 is t. This is x to the power half. So differentiate it. 3 by 4, x to the power 3 by 4 minus 1. So minus 1 by 4, dx is equal to dt. So dx is 4 by 3 x to the power 1 by 4 dt. And we have to compute x to the power 1 by 2 dx. So multiplying both sides with this. So here you will have 3 by 4. Okay. So this is 4 by 3 x to the power 3 by 4 is t minus 1. Okay. So this is, so if you know this belongs to this form, it's much easier for us. But if we do not know, we will keep on trying various substitutions. So this is 4 by 3 t minus 1 upon this thing is t dt. So 4 by 3 t by t, 1 integral of that will give you t minus 1 by t log t, and then you substitute the value of t back. Okay, next problem. Okay, we can continue with these problems tomorrow. So try more and more problems. We'll continue tomorrow.
Okay, so if it is varying with time or distance, then you have to write like this. And then you have to always talk about work between two limits. So that means I have a limit over here between xi say and xa. All right. So for a varying force, you have to write like this. Then there is another thing, when is the work is positive and when the work is negative. So we have a assigned sign, positive work and negative work. How do you decide when the work is positive and when the work is negative? Very simple, very simple. Only you remember the vector product. We have this one for a constant force. So if you express it, use the vector properties, then this is like this. Cos phi or cos theta, whatever is the angle between the two. If so, in the simplest term, if they are in the same direction, the angle is 0 and you have a positive work. We say work done by a force. Work is done by a force. Okay. When we say we are doing work, that means we are applying some force to an object and it is the force that is doing a work. Work is always done by a force. All right. So if they are displacement and force, they are in the same direction, it is a positive. So, but you don't have to remember all these things. The only thing is you have to remember is this vector product. If f and ds, they are in the same direction, the phi is 0 and you have a positive work. If they are in the opposite direction, phi is 180 degree and it is a negative. Okay. And other angles you can appropriately find what is cos phi. Okay, fine. Pardon?
If the displacement is zero,
Okay.
then is your work done?
No, work done is 0 then in that case. In that case, if you are asking this question, that if this one say
But if we are applying some force
and displacement is 0, that is what you are saying. When displacement is 0, either of these quantities is 0, work done is 0. Like,
there is a transfer of energy, there is a using of energy.
yeah,
Transfer of
okay,
energy to the
okay. What you are trying to say, okay, we take a concrete example, like we are pushing a wall. Wall is not shifting, but we are getting tired. So in the term of physics, we will say that the force that I am applying to a wall, to push a wall, it is not doing any work because the displacement is 0. But you are feeling tired. Why you are feeling tired? Because biologically your muscles are doing work. There is a movement at macroscopic level, at the biological level, at the human body level. Your muscles are doing work. At that level, muscles are doing work. There is a displacement. Maybe it is a micron level, very small level. So biologically your body is doing work. Your muscles are moving. So that is why you are doing work. Otherwise, so far as physics is concerned, your force that you apply on the wall is not doing any work. Is that okay? Okay, so I will take it. Any other questions? Yeah. So
I was reading in a definition that work is a transfer of energy.
we are coming to that. We are coming to that. We are just wait a minute. We are coming to that. So if let me again write it. Some now this f can be one dimensional along a x-axis. It may be along y-axis. It may be along z-axis. Or it may be combination in any direction. So a general form of f will be, say, fx okay, ijk vectors. So three-dimensional space that we live in. It can have a component along x-axis, it can component along y-axis, it can have a component along z-axis. So it is like this one. So this, you are already familiar with this. I will not take more time on this. Okay. Similarly, a displacement Ts can also be represented like this. Is that okay? Everybody is familiar with that? So if you take a dot product of these two vectors, what do you get? Is that okay? All right. Simple. Why I am doing this simple mathematics? Just because of a little bit of physics that is involved here. Now I can write this. This is total work done, or the work done by the force in displacement ds. This one I can write as wx. This one I can write as wy. This one I can write it. What it's simply, there is a physics involved in this one. It only says that the total work done by force F in displacing an object through a distance dx can be taken as sum of all forces, sum of the work done along x-axis, y-axis and z-axis. So that means they are scalar quantities, w, wx, wy, wz, they are scalar quantity. So what the physics underlies is that you can find the work done by x component of the force along x-axis, work done by y component of the force along y-axis, work done of z component of the force along z-axis, add them together and you will get the force. Okay, so it is a simpler way of finding the things. So that is why I am doing this. Now I come to the statement that one of our students have made. Work and energy. As you said, work is transferred into energy. I will come to that. Energy, there will be three types of energy. One is kinetic energy. I will take first kinetic energy. Then I have potential energy. Okay. So suppose I push an object, it starts moving. So what happens? What is physics wise what is happening is that whatever work I am doing, when I am pushing an object and there is a displacement, non-zero displacement, that means I have done a positive work over that. I have done a positive work. Now you find that the velocity or the speed of the object increases. So from there, so that means kinetic energy has increased. From where that kinetic energy has come into that? From my work, from the force that I have done. So that means the work gets converted into kinetic energy. Or the other way also. If a object is moving with some velocity, it can do push some other object, it can also do some work. So the both way. So work gets converted into kinetic energy, and we have a theorem known as work energy theorem. What it says, it simply says that work done is equal to change in the kinetic energy. Whenever we say change in kinetic energy, remember, whenever we say change in any physical quantity, it is simply the difference between the final and the initial. Between the final and the initial, not the other way. Whenever you say in physics, a change in some physical quantity, it is change between the final position value of that physical property at the final position minus the initial position. So, pardon? Yeah, it will not depend upon for a particular case when your force is conservative. Only for a particular case. We will come to that. So delta K, when you say delta K, it is simply Kf minus Ki, not the other way. Change is always, you want to find change, so find out what is the final kinetic energy minus the initial kinetic energy. So work done is equal to, this is also very clear, because you push, you do some work, then the velocity increases, part of the work that I have done goes into the kinetic energy. All right. Now come to the second one, potential energy. Potential energy, there is a problem. The problem is that you have to define some reference point. Like I raise an object from ground to some height, you know that potential is increased. Okay, but with reference to what? Kinetic energy is not with reference to anything. If kinetic energy is instantaneous thing, like an object has a velocity v, then its kinetic energy is half mv square. So it is measured at an instant. Which instant? When the particle's velocity is v, at that instant. So it has no reference, it is self-referred. Okay, but potential energy has a reference, because if I raise an object from this surface of this floor and to some particular height, its potential energy will rise. All right, no problem about that. But what is that value? You always say that, suppose this is 0 and I have raised an object to this point. If the mass is m, so what is the potential energy? mgh. This is h. So what is implied is the 0 point of h. The 0 point of h. Suppose you say that this is 0. This is my reference point. Then what happens? What is the potential energy? 0. It is 0. But again I have to do work. Like from 4th floor or 5th floor to 6th floor, I am bringing an object up. Okay, and this is my reference point. So maybe the potential energy is 0 with reference to this point, but still I have to do work, because I am going from a negative here. What is the potential energy here? Is minus mgh. So I'm going from minus to positive. Again I am increasing the potential energy. All right. So potential energy, you have to be slightly careful in when dealing with potential energy. You have always to work with reference to say a reference point. The second confusion with potential energy is potential energy is always of a system. Potential energy is always defined for a system. Kinetic energy is individual definition. Definition of is defined for a particular particle. There is no need for reference to a system. You may talk about kinetic energy of a system of particles. There is no doubt about that. But whenever you talk about potential energy of a system, like we are talking about potential energy of a object with reference to gravity. So what is the two systems? One is earth, the other is particle or whatever you call. Why? Why there are two bodies involved? Because as I said, when you are raising an object from say h is equal to 0 to say h to this point, you are increasing the separation between two objects. What you are doing is you are increasing the separation between two objects. That is why how you are raising the potential energy of one object with respect to the other. So potential energy is always defined for a system. Many times we don't say that. We don't say the potential energy of object is with reference to earth. We don't say, but many times you must say that. You must specify. So potential energy will be with reference to some reference point and with reference to some other object. Like moon is there, earth is there. What is the potential energy of moon and earth system? So it will be different. If you talk of earth and sun, then it will be different. So potential energy will always be for a system, while kinetic energy only for a particle. So there has to be two reference. One is the x is equal to 0 or wherever you define, where is the 0 point, or you can say u is equal to 0. So you have to define where the potential energy is 0.
Sir, when we talk about the Earth and Moon system,
Yeah.
then sir, what will be G? Is it 1/6 of G or?
No, 1/6 of G will be there only. Then you will talk only with reference to the distance between the two, and then this G will come. It depends.
Distance between their centers.
Yeah, between the centers. But it depends. You are talking about moon. One particle is moon, the other is earth. Then you talk about how the gravitational force between the two will vary. So that is a different thing. So you have to go to the general theory, G m1 by m2 is r is like this one. So you have to talk in a different way. So as I said, potential energy, you have to first define what is U is equal to 0, that means potential energy is 0. And second, you have to define that it is with reference to two particles. All right. Then we have a conservation law which says that energy, as there was a question, uh, the path independent work is the energy is work is path independent. Work done, but this is a qualified statement. It is path independent only for conservative forces, only for what does it mean? Conservative forces means I raise an object from this floor to a particular height, so I have increased the potential energy this particular object. Now if I leave it, that object will do the same work, that object will do the same work, so it will return the energy. I raise the object from say h is equal to x0 to some particular point, so I have increased this potential energy. Now if suppose I leave that object, so it will come down, so the whole potential energy will be converted. All right, so it will give back this potential energy to the system or whichever way you want. Okay, so that is why we say it is a conserved one. And only for conservative forces, like which are conservative forces, for example, one is gravity, this one is doing into gravity, the other one is electrostatic force between two charges. So any example of non-conservative force, like magnetic force, it is not an. Okay, any other example, like friction? Friction will also be not a conservative force. Whatever energy is required is spent against work against friction, you cannot take it back. So this is also a non-conservative force. Only for conservative forces you can define a potential. Potential is defined only for a conservative process. For non-conservative forces you cannot define potential. So this is something which you should remember. Okay, so what we are saying is, when we say conservation of energy, that means the total energy is equal to kinetic energy plus potential energy. Okay, and it is conserved.
Which conservative forces does not follow the inverse square law?
Which conservative force? Like you can say anyone, like your friction also does not follow in universal
But
square.
it's a non-conservative.
It's a non-conservative. Which conservative force?
That does not follow the inverse square law.
Which
Electrostatic force and gravitational force.
Yeah.
Those are both are follow the
Inverse square law. There are like many force, but conservative it may not be conservative. No, no. You are.
Give me that one force which does not follow the inverse square law, but that is conservative force.
I don't remember any. I don't remember. I don't remember, because there are forces which, if it is not inverse square law is like your gravitational is inverse square law, and electrostatic is also inverse square law, but it is they are conservative. They are conservative because Gauss's law apply to them. They are conservative. But to there are forces like nuclear forces are there which are non-conservative and which also do not follow the inverse square law, like nuclear forces. Nuclear forces are non-conservative and also do not follow inverse square law.
Is there a force that
No, to my mind, it does not come to. Maybe we will explore it and come back to you. Okay, so total energy is kinetic energy plus potential energy. And there is another energy potential which we can classify as potential energy, which is spring energy, a spring force. Spring force, what is this force? F is equal to kx. No, force is equal to this one minus kx. So minus sign, you also have to be very careful about minus sign. What it means? It simply means that if you stretch it, so again you have to talk with reference to a sub. Okay, all right, let us. So this is a reference point. Okay, say this is unstretched spring. This is x is equal to 0. Okay, now I stretch it. It comes to this position. Okay, all right, this is final position. I have stretched it. So what will happen? The spring will try to pull it back. So your force is the other way. Okay, the force is other way, and x is, where is the displacement? Displacement in this way, and force is in this way. All right. So that is what this one says. And suppose you do the other way, you compress it. I compress the spring. Suppose I have compressed it. What will happen? Which way the force is? Force is in this direction. Okay. All right. So force and x is the change in position, or you can say change from equilibrium position. Change from equilibrium position. Yeah.
But when we have the condition that force is acting in this way and
No, we have not condition. We have not condition. No, we have not condition. Only the spring is dictating us. Because if you press the spring, it gives you a thrust. You can see it in your daily life. If you press the spring, it gives you a thrust. So that means it is working in this direction. And if when you stretch it, then it tries to pull your hand. So that it is the nature of the spring only. Not we are not manipulating it. So change in equilibrium position. This is equilibrium position. So always you have to talk with reference to something. Why this reference is coming? Because this is again a potential energy. It's not a kinetic energy. Whatever work you have done, it is stored in terms of potential energy in the spring. And what is that energy? You can find out what is the work done. Work done is F. Why I have to take integral? Because this is a varying force. This is not a constant force. So I have to write F dx, and let us say x is equal to 0 to x, and F is equal to minus kx. So this is how much? Minus kx square by 2. All right. So this is the change in potential energy. This is the work done, which we write in terms of change in potential energy. So this is written like this. Work done is change in potential energy. So what is the work done here? This is minus half kx square by 2. Okay. So what is the change in potential energy? Delta U is equal to minus W. Okay. So what is this? So there should be no confusion. Work done is negative, but change in potential energy is positive. Whether you compress it or whether you stretch it, the energy increases. Energy of the spring increases. Whether you compress it or whether you elongate it, the energy increases. What is positive and what is negative is the work done. Why? Because the force that you apply depends on the relative displacement. They are opposite in one case, they are in the same direction in the other case. Therefore, the work may be positive or negative, but the energy is always positive. Energy is always positive. Only with reference to some reference point you may find it is negative or otherwise, but it is always positive. So your conservation of energy statement is kinetic energy plus potential energy is constant. So I can just take it the other way. In many situations I can take it, vary it. So what is variation in E? It is a constant, so this is 0. So many problems we will use this property. E is equal to constant, that means E initial final is equal to E initial. Whatever the energy, total energy in the final configuration of a system, whatever the total energy in the initial configuration of the system, they are equal. It does not change. For what? For which type of forces? For conservative forces. Only for conservative forces. So you have to qualify it. But sometimes we can use frictional forces also. We can include frictional forces also here. We can include frictional forces also here if we know what is the value. If we know what is the value, we can also include it. So if you vary it, that means any variation in delta E is 0. So this is the delta K plus delta Y is 0, or you can say so. Can I write it? I can write it like this: delta K is Kf final kinetic energy minus initial kinetic energy final potential energy minus initial potential energy. So we will use this property at some places. Let us now do some problems. One problem that is the last problem in my list. I want to do it in the very first because I am sure I will not get time for that. So this is a very interesting problem. So this is inclined track, and then both sides is like ball, okay, and we have an object here. Object is held by hand or some means at a distance. This is L by 2. This horizontal track is of length L. And the coefficient of friction is there is a friction on this surface. So coefficient of kinetic friction is, let us say, 0.2. Okay. Now I drop this ball, and these are frictionless. These two surfaces are frictionless. This is also frictionless. The question is, where will this object stop? So we will use the conservation theorem, we will use the energy work energy theorem and find out where this will stop. So you can find, first let us find what is the energy. Using Newton's law is out of question. You cannot solve it because many things are not given. So let us find, if it is at L, height L by 2, what is the energy it is having? It is the only the potential energy. So there is no kinetic energy in this one. So what is the total energy? Let us say this is initial position. What is the total energy? Is equal to mg now. Should we write plus sign or minus sign? Minus. Why? It's going, no, not, don't remember downward, upward, forget about that. You, what is your force? Force is mg. Force is mg. Don't, if you talk physics in this term, you will be confused. Your force is mg. It's a gravity, it is mg is always downward, okay, and h is also downward. Displacement is also L by 2. So what it should be? Should be positive or negative? Be sure. Yes. Yes. Any question? No. Where is the force? Force is this way. Mg is this direction, all right. And then this one is this. H is in this direction. So your energy is, work done is, let us say work done is, work done. Let us find out work done. Now work done is F dot ds. What is this value? Work done is positive. Okay, work done is positive. There is no question about that. You can see mg and h, they are in the same direction. So even if I assign some vector, you can find out. So this is no problem. This is mg, L by 2. But just now we have told what is the change in potential energy. Change in the energy. This is change in the energy is, okay. So U will be, delta U will be all right. Is that okay? Any confusion? Okay. So what is the energy? My initial energy is, let us say take this one is the change in energy. What is the final energy? Suppose it stops somewhere. At some point it will stop. At that point it has no potential energy because it will stop here. No potential energy, no kinetic energy. So this is your change in energy. So the change in energy of the system is this much. Now when it starts moving on this surface, there is a frictional force, kinetic friction. So friction force will try to resist this motion. All right. So the friction force will do some work. What is that work? Again, work we can find out. F dot. What is force? Frictional force. Frictional force is mu mg. And always it will oppose the motion. So we have to write a minus sign here into distance. Let us say any distance. Let us say it is whole, it is distance x. All right. X distance is moves. Okay. So this is the work done in moving x distance. All right. And mu is equal to 0.2 into some x. All right. Now your energy, how much is your energy? Let me write it this one. This is 0.5 mg and what is this energy? 0.2. They are both of course minus. So what is the ratio? Let us find out. What is the ratio of the two? One is 0.5, one is 0.2. So it is this one has energy of 0.5 into some this constant. Mgl is a constant. So it has 0.5 into something. Here it is 0.2. Suppose you put L, whole distance you want to find. So this is 0.2 ml. Whole distance is goes from this point to this point. So the energy that is spent against the friction is 0.2 into mgl. This total energy is 0.5 into mgl. What will happen? It goes from here to here. It spends 0.25 mgl energy, and it is left with how much? 0.3. So again it will go back. Again it will spend how much? 0.2 mgl. Again it is left with something. 0.1. Very little, very little line. 0.1. Just find out. 0.2 is required for full length. So 0.1 is half of this. So that means it will come to this point and it will stop. So I just did this one because I don't have time for that to reach the 12th one. So, but this is a very interesting one. So, can we go to slides now, please? This problem one is simply selected because of a concept of physics which is usually not given attention, which is where this centripetal acceleration, when we talk about circular motion, when we talk about circular motion, usually we talk about uniform circular motion. And then you say that uniform circular motion, V is constant. And we have a centripetal acceleration working towards the center. That is given by how much? V square upon R. Acceleration is V square upon R. All right. So this is true only for a uniform circular motion. Suppose V is changing, what will happen? In that case, that is where this problem comes into. V changing, that means non-uniform circular motion. So I have an object, it is moving. It has a velocity over here. So this velocity, this gives, suppose V is constant, then it gives rise a centripetal acceleration like this. So it is, you have a centripetal acceleration. But suppose V is changing. V is changing. So what is the acceleration? dV by dt is the acceleration if V is changing with time. So we will have another acceleration in which direction? In this direction, which is known as tangential acceleration. So you will have acceleration which is known as tangential acceleration, and you will have this acceleration AC. So the total acceleration is somewhere here. This is the total acceleration. For a non-uniform motion, we have two components of acceleration. One is which takes you towards the center, that is known as centripetal acceleration. But there is another component of acceleration which takes it along this one, along the tangent, which is known as tangential acceleration. While this one will not do any work. Because why? Because it is always perpendicular to the displacement. So this will not do any work, but this will do work. Because the angle between this acceleration or force and the displacement is 0. So that is where this problem first comes into. Let us do it. This was one of the questions asked in JE. So it is given as, can we have problem number 1, please? Yeah. AC is equal to K square R3 square. So it is time dependent, you can see. So we can write it, this one as V square upon R. So what is V? V square. V square is equal to, try to do it. Let us see. What is V square? Find out V. Just do it. Find out V and then find out tangential acceleration. Find out what is V, differentiate it with respect to time. This is equal to V square upon R. So find out what is V. Then differentiate it with respect to t, time. You get it. Okay. And then, so that means you get what is, you get V AT. AT you have got. Oh, what is the force? Tangential force. Tangential force is equal to mass into. Okay. Then find what is the work done by tangential force. Okay, it is what they have asked is for the power. Power delivered. Power delivered is also there is equation FV. Or if they are in the same direction, you can write. So can you find out what is P? How much P you get? What is M 80? 80, how much you get? 80 Kr. So M Kr, okay. And then what is V? P is equal to M Kr into V is equal to Krt. So how much it is? M K square R square T. But you must be careful, this power P is the instantaneous power. This is the instantaneous power. That means power at a particular time. It is not the average power. It is not the average power. That means in terms of calculus, P is equal to this one. And your average power is defined as total time and total work done. You can find average power. So this one is essentially power. That is where this one comes into. Second one is very simple. So I just want you to do it yourself. Can you attempt the second one? Second one, when a rubber band is stretched, just 2 minutes, it should not take more than 2-3 minutes. Can we move up, please? All right. Okay. Force is given. It's a simple one. Is it not simple? Force is given. So you have to simply integrate it. How? Pardon? No, you have to integrate it. Up to 0 to L. Okay? Anybody? Yes? It should be. Okay, simple one. A L square by 2 plus. All right, fine. Simple, very trivial, simple one. All right. So we go to the next one. Yeah. Integral constant you can take. Okay, fine. C has a good question. Let me see. If C says that you are integrating it. Okay, just a minute. Just. You are saying that you are integrating it from 0 to L. So you take the limit 0 to L. Even if I can, even if you don't do that, say suppose you are only putting x is equal to L. So that is not the way. But even if you do that, I have my C is 0. How? When x is equal to 0, your force is 0. So even if you don't do that, my C is 0 because F is equal to 0 for x is equal to 0. So my limit will be, that is why I told you the work, whenever you call F work done, you always define between what limits. Work done from this point to this point, from point A to point B, from 0 to L. Unless you define the limits, your work done cannot be precise. Okay, so we go to question number 3. Question number 3. This is also a JE problem, simple JE problem. Let us first, diagram is not given here, but we can make the diagram. A circular track is there. All right, a circular track is there, and it has a radius of 40. So let us say So this is 40. This is also 40. There is a block here over here. The block slides along the track without toppling, and friction force acts on it in the direction opposite to the incident velocity. The work done in overcoming the friction. Can we go up, please? Can we go up? Next page, okay. Okay, to point Q. So there is a point Q here. So, and this angle is also given actually. This angle is 30 degree. What is the speed of the block when the block reaches point Q? What is the speed of the block? We will use the energy theorem, work energy theorem. What is the speed of the block when it reaches Q? How do you solve it? Let us use the work energy theorem. Find out what is the, when it comes from this point to this point, what happens? The potential energy decreases. If this is a reference point, x is equal to 0, when the block comes from this point to Q, the potential energy increases. That decreases. That decrease in potential energy is the gain in kinetic energy of this. So if suppose m is the mass of the block, and what is the decrease in potential energy? Let us find out. What is loss in potential energy? What is that? Mg. So your Mg, we are already using the word loss. So we can write it in a positive terms. Mg into the height, whatever height it comes. How much is the height? How much is the height? We have to find out that height. This height is like this. This one. How much is that height? This is known. This is again a radius. This is again a radius. So this is 40. This angle is how much? 30 degree. So what is this one? Can you write it? So this is, let us say this is h. So h by, how much is that? H by 40. H by 40 is sine 30. Isn't it? So what is h? 20. So okay, fine. So what is the loss in potential energy? Loss in potential energy is mg into 20. Mass is given. Okay, so write it. So find out, and then gain in kinetic energy. How much is that? In kinetic energy is half mv square. We are asked the velocity. Okay, so half mv square. Okay, we want to find v, but there is another loss in energy. That is a friction. So part of that energy, potential energy, goes into overcoming the friction. So how much is that? Is already given there. 150 joule. So that means your this mgh is equal to 150 J plus half mv square. Can you find out v from this? Fine. So others, let others do. 10 meter. Fine. Very fine. Now come to the next. Everybody is 10 meter. Everybody. Okay, fine. What about the second part? What is the magnitude of the normal reaction that acts on the block at point Q? So how do we do it? No, just think about. First, use the free body diagram. In the beginning, you should not jump to the, use the free body diagram. At point Q, what are the forces? mg, and then there is a surface here. Because of this surface, there is a normal force towards this center. Okay. And then there is a velocity also along this. Okay. So, and then mg, what is this angle? We have already found out. The angle is, what is this angle? Is will it be theta? This is like this. Okay, so these are parallel. So this is theta 30. This is 60. So this should be 60 actually. 60, isn't it? It should be 60. So what are the forces acting on the particle at point Q? One is the mg. The other is the normal force. Okay, so mg cosine is 60 cos 60, and then there is a normal force, but they are not equal. Why they are not equal? Because the particle is not stationary. Particle is not at rest. If it is at rest, then they are equal. But the particle is moving with the velocity v, so therefore there is a centripetal acceleration. There is a force toward the center. If it is not moving with the velocity v, then of course n is equal to mg cos theta. There is no problem about that. But since it is moving with velocity v, therefore there is an acceleration over here. And this force, centripetal force, is actually is equal to n minus. Centripetal force, as we told you, is nothing but the actual force. Actual force that is working towards the center. So this Fc is equal to, what is this? N minus mg cosine 60. And what is this? How much is this? This is mv square upon r. Can you find now n from this? 5. No, so find out from this equation what is n. Yeah, v is given, r is given, m is given, everything is given. Find out. 5 point. 2.5. No. N is equal to this much plus this. What is this value? Just calculate it. Yeah, what is m? M is how much? M is 1 kg. Okay. 15/2. Fine. 15/2. तो प्लस आप देखिए ना होता है कि नहीं होता है. तो आपको सोचना थोड़े, मैथमेटिक्स में ज्यादा नहीं सोचना होता है. वंस यू सेट अप द इक्वेशन, अदर थिंग्स फॉलो. तो आपको आंख मूंद के फॉलो करना है, रिलीजियसली जिसको बोलते हैं इंग्लिश में. आपको एक बार इक्वेशन सेटअप कर दिया, यू आर कॉन्फिडेंट अबाउट द इक्वेशन, देन यू सिंपली फॉलो इट. उसमें आगे कुछ सोचना नहीं, आंख मूंद कर फॉलो करना है. ये इसमें जुड़ जाएगा. दिस इज आई थिंक कमिंग अबाउट हाउ मच? 2.5. mg cos theta is 5 and this is 2.5. So it will become 7.5. N is equal to, is that okay? Everybody got it? Okay. So can we go to next one? Question number 4. This is another interesting problem. We have a chain, so it's lying on a table. You see, physicists are very imaginative, very creative. Of all the subjects, they are most creative. In the sense, I am not, saying anything about other subjects, but they are very creative. So they can think of problems. They can. It is only physics where you have thought experiments. Einstein did thought experiments. So you can think of thought experiments and you can get results also. So you can come out with many situations wherever you find they create problems and solve it, and when the solution is plausible they do it. So like this one, there is a chain. So we have a chain here. One fourth, what it says, one fourth is hanging over this. Okay. So this is L by 4, this is 3L by 4. Nothing more, nothing less. Or mass is also given. Only two things are given. Mass is given and length of the string is given. How much work is required to pull the hanging one on the table? So you just, it's like any situation, you just pull it slowly and slowly, so that this one goes over here. So how much total work is required? How to do it? This problem. How to do it? Because what is happening, I can do it very simple. Because the force of L by 4, this is a constant one. So there is no change in potential energy of this one. Only happens when this goes up, there is change in the potential energy. If you consider in a very gross term, Cg will be somewhere here, half of this L by 8. Cg will start moving up. So there is a gain in the potential energy. All right. So that is the work you have to do. So suppose this one we take as a reference point. So U is equal to 0. And consider any small portion of this one. We divide it into a very large number of small portion we consider. So let us say a small portion of dy we consider at a distance y from top. Okay. So what is this? What is the mass of this small section? Mass per unit length is uniform chain, mass is m, length is l, so mass per unit length is m by l. So what is mass of this dy? Mass is mu dy, so is equal to what is force acting on this one? Gravitational force. What is the force acting on this one? G mass into G. That is the force. That is the force. Small mass, whatever this portion, that is the mass. And then you want to move it up. You want to move it through some distance, say y distance. So work done is this. And your y changes from 0 to L by 4. So your y changes from 0 to L by 4. So integrate it. How much you get? So work done is 0 to L by 4. Of course, there will be minus sign here. So m by L dy y g. Can you find out what is this value? L upon mg L upon 32. So that is the work done. The potential energy will be in minus of this. So mg L square or L by 32. So this is the amount of work that you have to do in pulling the whole 1/4 part to the table. So you find that you cannot solve this problem by using laws of motion. Newton's laws of motion you cannot find. Only by using the work energy theorem and conservation of energy properties you are able to solve it. All right. Is that clear to everybody? What will happen in many examinations? They may change this L value. In some question they may say L by 8. In some question they may say L by 2. Or L by 3. Things like that. Or even they can say what is the velocity at this point. So there are variations, various forms of these questions are available, but the concept is the same. Can we go to the next? Okay. Okay. So let us first visualize this question. So we have a target, something like this. I'm sorry, this time I could not bring the diagrams. So there is a spring and this is fixed on a surface. And we have a projectile or say some small particles of mass m, and this is moving with the velocity v. It is shot into this one and the spring constant is k. This target, this is a frictionless surface. So that means once this one hits it, it can move, freely move on the surface. Okay. Now the question is, the target, this is initially at rest, this is the target, this is initially at rest and can slide without friction on a horizontal surface. Find the distance delta x that the spring compresses at maximum. So when this one strikes it will compress the spring. So you have to find out how much the spring is compressed. So delta x we have to find out. So how to do this problem? Again use the energy, or use the energy theorem, conservation of energy. So what will happen? What is the initial energy of the whole system? Let us say whole system, this has no kinetic energy, no potential energy. This one has a kinetic energy. So the initial energy is half m v square. What will happen when you strike it? What will happen? Both, it will transfer energy. So this will be compressed, but looking from outside, what will happen? Both will start moving with some velocity. So let us say that velocity is v dash. Okay. So this will be embedded into this. All right. So my mass becomes half m plus m. Both move together. Okay. And then your velocity is v dash square. But the energy, this energy, kinetic energy goes not only this one, it also goes into compressing the spring. So how much is that? If delta x is the compression, what is the energy? Half k delta x square. Is that okay? Is that okay? Perfect, no problem. So from this we want to find what is delta x. How can you find? There is only one equation. There is only one equation. There are two unknowns, v dash is unknown, delta x is unknown, and we have only one equation. So we have to find another equation. How to find that? How to find that? How to find that? Another equation. Any other physics property we can use it here? Any other conservation laws? Law of conservation of momentum. Let us use it. Okay. So conservation of momentum, what it says, initial momentum is mv, final momentum is okay. So we got two equations, two unknowns, two equations. Solve it, find out what is delta x. Is that okay now? So we have used conservation of momentum. So v dash, find out from this second equation what is v prime. Substitute the value in the first one, find delta x. Yeah, there will be some under root, but one quantity will be outside under root. Yeah, velocity will be outside. Okay, how everybody got it? How much is that? How much is that? Delta x is equal to how much? Under root. How much is that? V is outside. V will be outside. It has to be outside. Okay, because this is a, why I'm saying it has to be outside. Dimensionally it has to be outside, because this is a displacement, this is a distance. It has to be multiplied by velocity and some time, something like that, or some quantities like that. So what is this value? Numerator and denominator, what is that value? It will be in terms of m. What is that value? Yes, pardon? No, should we work out? Okay, let us see. Should we work out, or it is left to you? Should we work out from this equation what is v dash? V prime is equal to m divided by m plus m. This is okay. We substitute that value over here. So we have half m v square is equal to half m plus m v dash square. So that is v prime square m by m plus m. Is that okay? Plus half k. Somebody should be able to find out what is the value of delta x. So simplify it. Yes, all of you agree with some result or not? This is simple mathematics. So let us find out. Half kx, half is cancelling out, so I will just cancel out. So k delta x whole square is equal to mv square minus, so this one goes, one of them will go, so this is m square divided by this. So this is half mv square minus m square divided by m plus m v square. Is that okay? So I take out v square common. Okay, then m is also common. M is also common. So we have here m plus m minus m. Is that okay? So simplified, if you simplify it, so this is how much? K delta x whole square is equal to m capital M, then small sum of the two into v square. Is that okay? So what is delta x? Delta x square is equal to k. Okay, this is under root. I take delta x. Okay, and this is v. Now check whether this is dimensionally correct or not. On the other side we have velocity, at this side we have x displacement or distance. Is it okay? Dimensionally okay? Is this result dimensionally okay? Is this result will the right hand side have the dimension of x or not? We want to check it. How to check it? Mass is mass, so no problem. So m into m. This is a mass, so m. It will have how? L आएगा. तो कैसे? ठीक है, एक कट जाएगा, ये हो जाएगा मास. ओके, m के आ जाएगा. हाँ ठीक है, फाइन फाइन. ठीक ठीक है. ठीक है. So this will have a dimension of, this will have a dimension of length. It has to be a dimension of length. Otherwise, what is the dimension of k? By the way, it is k, f is equal to kx. So f is Newton divided by k is Newton by meter. So you can use even if you want to put the units, you can find it. There is no problem. So let us put the units. This is kilogram, 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 then Newton divided by meter. Okay. So what is Newton? Newton is kilogram into meter only. So okay, fine. So kilogram into meter. All right. So you can find it, no problem. Can we go to the next problem? We have some time, another 2-3 problems. Okay. Pardon? Question number 6. Huh. From, okay. Okay, fine, fine. All right. Yes, what is the question, please? Yeah, potential, yeah.
So why did we maximum compression?
Yeah, yeah, your question is all right. What he is saying is, you ask about maximum compression. We are asking about maximum compression, because only in this position maximum compression velocity is 0, and everything is transferred into potential energy. Everything is, so V is 0. So that is why we are asking maximum compression. In this position velocity is 0. So what we said is the initial energy is only half mv square, and the final energy we are saying as half m plus m v square, because what will happen, this half k delta x square, this is what we are talking about. This is a maximum compression. By spring by nature cannot be left like that. Suppose you have pressed the spring by some force, at momentarily it is at rest. After that the spring force will act it. So even within the system there are internal forces. So there will be realignment. The spring force will work it, and it may try to push the projectile or the object to some distance, of course. All right. So that is why it says only maximum distance. After that it says full stop. We are asking only about the maximum distance. That is also only instantaneous, only for a particular instant of time. After that other things will happen. This spring force will start try to push the projectile outward. So that is, we are not going to that one. Can we move now? Any other questions? Any other questions? Okay, so we go to the next one. Fine, this is fine. We can talk to others. So next question is, yeah, okay. Question number 7. There is another type of problem where the pardon, sixth. Okay, let us see. Sixth is okay. Sixth. Fine. So this is another type of problem where two masses are connected through a string that goes over a pulley. Simple one. So I have we have a pulley over here. We have collected different types of problems. Okay, and then we have a two masses are there. Two masses are hanging. One is what is the mass? One is 0.36. Okay. Okay. And G, of course, is saying G is equal to 10. Just to simplify the things, find the work done by string on the block of mass 0.36. Work done by string on the block of mass 0.36. So that is the work that you have to find. During the first second, so what is happening? If this is the system, this is 0.36, this is 0.76. The moment you release it, this will start coming down. So it will set the whole thing into motion. Okay. So this will go up, this will come down. So what is the forces? One is the tension. So what is the question? Question says that find the work done by string on the block of mass. What is the string? String will not do work. It is the tension that will do the work. Okay, so that means you have to find the tension. So how to find the tension? Use the FBD, free body diagram of the two masses. Write the free body diagram of two masses. Let us do it. So one is this. Okay. So we have this equation, point T minus 0.36 T is equal to, into G is equal to M1 0.36 into acceleration. A is the acceleration of the whole system. All right. And what about this one? This is 0.72 minus T is equal to 0.72 A. So solve it. Find what is A. What is value of A? Add that, T will cancel out. You will find out what is the value of A. A is equal to, so this is okay, 0.72 minus 0.36 G divided by okay, how much it comes? 10 by 3. Okay, fine. 10 by 3 meter per second square. So can you find out what is T? T. How much is T? Substitute in the first equation. Find any equation, first or second. Find out what is T. As we have told you in the last session, you can use the trick also here. So now you have understood what is the physics. So you can use the trick. You can extend the whole thing on a plane, put it on a plane. So A is the acceleration. So you don't have to remember all these things. You have to simply write that A is equal to m1, m2 is this one, m2 minus m1 g divided by m2 plus, that is what we are getting, 4 point, tension is 4.8, okay, 4.8 Newton. Everybody agrees with this? So what is the work done by this rope on this object in 1 second? So, pardon? So we have to find out what is the distance traveled in 1 second. What is the distance traveled in 1 second? How to find? Okay, so use it. What is distance? You have the acceleration. You have the acceleration. Okay, so distance you have to find out. So that I can use this. S is equal to ut plus half at square. U is 0. U is 0. T is 1 second. So S is equal to how much? S is equal to half a t is half into a t square. T is 1. So half a. A how much you found? A is 10 by 3. Okay. So 5 by 3. Okay. Meter. So what is the work done now? What is the work done? 4, 5, that is distance is 5 by 3. And what is the force? Mass into mass, how much is mass? It is the 0.36 into mass into acceleration. Acceleration is how much? 10 by 3. Is that okay? Mass into acceleration is the force. So, okay. So, no, sorry. So tension is there. So 10 by 3 is the tension. Okay. So it is 50 by 6. So 4.8. Okay. Okay, all right. Just a minute. This is T into distance. So what is T? T is how much? 4.8. Okay, just a minute. 4.8 Newton. And distance is 5 by 3. Yes. All okay. Is everybody gets it? You should be, every one of you should be able to solve problems with me. That is the main purpose of this exercise. If you are not able to go with the class, then there is no point in doing this exercise. Okay, so can we go to the next problem? Problem number 7. Just visualize this problem. A block of mass 0.18 kilogram is attached to a spring of force constant this. The coefficient of the kinetic friction between the block and the floor is 0.1. Initially the block is at rest and the spring is unstretched. Okay, so there is a okay, so let us say, so you have a block, it is attached to a spring. Mu is given, kinetic friction is 0.1. Initially the block is at rest, as you see, and the spring is unstretched like this one. An impulse is given to the block, say let us say some impulse is given. Okay, impulse is, that means you have given some momentum to the block. Okay, impulse is given to the block slides a distance of, so this is say x is equal to 0. When impulse is given, what will happen? This will compress the spring, it will slide down, slides to a distance of point say 0.6 meter, and it is says comes to rest for the first time. Again, this language is very important. For the first time, point 0.06 meter. 0.06 meter. This language is very important. The block comes to rest for the first time, because what will happen? This will come to rest under this impulse, but it is only momentarily at rest. After that, this spring force will come into action, because you have removed the impulse. So this will come into action, spring force will come into action, it will push the block. That is why this question is very important. In the previous question also, that is why it asked for the maximum displacement. Maximum displacement is where the velocity becomes 0, it stops. All right, so that is why there was, the question was maximum displacement. Here it is for the first time. If you don't write this, then there is a problem. For the first time, the initial velocity of block is n by 10 meter per second. What is the value of n? So we have to find out, use the energy conservation theorem. So let us say this is the velocity is v. Okay, the velocity is v. Suppose the initial velocity of the block is, let us say v. So what is the kinetic energy of the block? Kinetic energy of the block is half mv square. It goes into, what are the things it goes into? One is that it will compress the spring, so it will go into increasing the potential energy of the spring, half kx square. What other things it will do? It will do work against the friction also. Okay, so just set the conservation of equation. How much it compresses? What is the total energy? How much is the compresses? So this is half mv square. So this is the initial energy we had. Part of it goes into compressing it. How much is compression? 0.06. 0.06. Okay, so 0.06 into say half kx square. This is the potential, this is the spring energy. Then friction, some friction energy. It is given there? No, it is not given. So you have to find out what is that? mg, mu mg into whatever is the displacement. How much is displacement? So this is the 0.6 meter, whatever is. So you solve it, then we have to find out what is value of v. K is given, k is equal to, mu is given, mu is equal to 0.1, m is given. This is over. Okay, try to solve it, and then next time, this is simple one, you can solve it. There are other questions. Can we just go for the other questions? Question number 8. 8 is slightly difficult, but not much. 8, 9. Try to do all these questions. If you have any problem, next time we can discuss it, or I will just supply you with the answers. There's no problem. Thank you very much. Saturday you get less time. You get only about 100 minutes or things like that. On Sunday you get more time. Yeah. Yes.